Hi everybody, Dr. Liz here. I'm going to go through your pre-lab lecture. I went over this last week, but some of you may have forgotten. I also kind of want to make a note. Several of you have written me asking questions about calculating the concentration of the iron thiocyanate. I went over that in the pre-lab lecture last week, so please make sure when I'm doing pre-labs that you're taking notes, writing things down. That's when I give all the details on that kind of thing. So for those that are still questioning it, how do I calculate, or how do you calculate the iron thiocyanate concentration from last week to do your calibration curve? Well, think about what you need for concentration: moles and total volume in liters. How can you get moles of product? Well, last week on the handout and what I talked about in class is that the thiocyanate is the limiting reactant. And the balanced equation says it's a 1-to-1 ratio of these two. So, in other words, figure out how many moles of thiocyanate you put in that total mixture. You've got your total volume used, put that in liters, and that's your concentration then of iron thiocyanate. Okay, so this isn't exactly what you're going to look like. I threw some just random numbers here. You're going to take your concentration curve from last week, and again, you should have a point, that's at 0, 0. The blank that we did needs to be plotted. You had 0 concentration, we set that at 0 absorbance, and then you have 5 additional points or solutions that you made. Actually, maybe you only have 4 additional ones. I say that. Uh-oh. Guys, did I make a mistake? Uh-oh, let me look. You have... The blank is number 1. So, okay, so let me take one of these away. I got too carried away. Okay, that's fine. All right, so your first solution was the blank, and then you had solution 1, that was solution 1, then 2, 3, 4. And as I said in class, and I think everybody was finding, as you increased the concentration, you had an increase in, absorbance. So there should be a fairly linear relationship, meaning proportional. As absorbance increased, you should have calculated an increase in concentration. Again, these are not the right numbers. I just threw some numbers on here. But I wanted to show you what you do with your curve from last week. And again, you're going to turn this in. Instructor Lipton will be here tomorrow to collect your stuff. I told him or her, they're a husband and wife team. The husband might get you started and the wife might finish. But I've told them that I'm giving this pre-lab lecture, so basically they're just going to come in, let you go at it. You're not really doing anything new from last week, so it should be pretty straightforward. Okay, so you've got your concentration curve. You're going to turn this in with your worksheet, the handout that I gave you last week. Staple those. Turn that in, but note somewhere what your curve looks like, okay, because you're going to need that. But they're 2 separate labs. So this and your pre-lab, because remember you didn't have a pre-lab last week, your pre-lab for this lab is due tomorrow from the book. Okay, so I keep digressing, I'm sorry. So you got your concentration curve that you created with your data from last week, and you have this equation for the line, and just based on, whoops, let me try and blow this up a little bit. Let's see if it'll let me. Maybe it's not going to let me. Okay, but you can see what it is. Y equals 8.192x plus 0.0833. And in fact, let me put that somewhere on here. Y equals 8.1912x plus 0.0833. Okay, so since I didn't label these axes, sorry, I was just doing this quickly. This is concentration on the x-axis, absorbance on the y-axis. And again, your absorbances aren't going to be this high. Everything should be less than 1. But again, I just threw numbers up there. So that's what it should essentially look like. So this week what you're going to do, you're going to make new solutions. I tell you exactly how much volume to mix. You're only doing 10 milliliters, so you're going to use what I like to call the baby volumetric flask this week. Same idea. You're going to use the pipettes. I know you loved those last week. You're going to use the pipettes to make solutions. You're going to dilute it up to the line. Your total volume, though, will only be 10. And hopefully they're going to set out enough 10 milliliter volumetric flasks that, like last week, you can prep them all at once and then just draw from each, put it in the cuvette, and record your absorbance for this second week. So once you have an absorbance of its product that we're looking at the absorbance of, because that's the colored solution, Once you have the absorbance for your solutions, then you're going to use this equation. So for example, if solution number 1, this second week of lab, has a measured absorbance of 0.5, use the equation of the line from the calibration curve to determine the concentration of FeSCN, and it has a 2+, so the product, in other words. Sorry guys. Okay, so use that equation of line. So let's say if I had the 0.5, let's see, and absorbance, remember, is on the which axis? Concentration is on the X, absorbance is on the Y. So again, my absorbances are kind of wonky, but that's okay. Again, I was just throwing numbers out there. Your absorbances should all be less than 1. But you use the equation of the line. And again, what did I just say? Absorbance is on the Y-axis, or concentration is on the Y-axis. Do you remember? Do you remember? It says it. I got to pull your handout out. It says it on your handout that you put the absorbance on the Y and the concentration should be on the X. So make sure that that's what you did. Again, over here, I didn't label the axes because I was just throwing some numbers together to give you an example that we can work through. Okay, so if my absorbance is on the Y, and if I, in this week, measure an absorbance of 0.5, I'm going to plug that in for my Y. So 0.5 minus 0.0833, and then divide it by 1912. You guys can't see me type it in my calculator. So my concentration, let me just copy paste this. For trial number 1, for my trial, I don't know why that's so big, is my concentration is 5.09 molar. Okay, now what does that mean? Well, first thing is you're going to calculate that for all the trials. Okay, based on the absorbance that you measured this week in week 2 with your new solutions. Now, unlike last week where we used so much of the iron 3 nitrate that we pushed it essentially into a one-direction reaction, this week we're going to use much lower concentrations and much smaller amounts, so it will truly be the reversible system. We're not going to use Le Chatelier's principle to kind of trick it into it. Okay, so what that means is, on my ice table, you're going to want to create an ice table. At equilibrium for trial number 1, I determined that my concentration of product is 5.09 molar. Now, I need to fill this whole ice table in, even though it doesn't really ask you for an ice table, but that's essentially what you've got to do for each one. When you read the lab, it steps you through the process, okay? And eventually what you're going to calculate is a KEQ for this reaction, okay, of my product over my 2 reactants. But I need to know what those concentrations are at equilibrium. Now, I just got it for the product. However, I've got to go back up here and kind of figure things out, finish my ice table so that I can get these 2 values, the equilibrium values for iron 3 and thiocyanate. Now, the lab, if you look through the lab, and in fact, let me flip my own book to it. I can't show you my book, but I can, excuse me, I can walk you through what's going to happen. Oh, one other thing really important, guys. You're only doing method 2 only this week, okay? I'll remind Professor Lipton we're not doing method 1. Okay, so once you start actually calculating data, what it has you do, it asks you for the number of moles of, initial moles of each reactant. It doesn't ask you for initial moles of product because there is no product initially. You're mixing so much iron nitrate with so much potassium thiocyanate. Now, how do you figure out initial moles? Well, you know a concentration. It's on the bottle and it's also in your lab. My page doesn't have a page number, but it follows page 44. The same data and calculation sheet where it tells you how much you're going to use of each reagent. You're going to pull that concentration, and you know the volume that you're using. Volume and concentration is all you need to determine the moles of each initially put in the container. So you do that first. Do it for each, and so I'm just going to throw some numbers out here. In fact, hang on, this is equilibrium, moles and equilibrium molarity. It's going to ask you for both, okay? Now I can figure out my equilibrium moles, again, if I know molarity and I know my total volume. For instance, let's say in my made-up mixture here, let's say my total volume was 1 liter. Well, then I had at equilibrium 5.09 moles. Okay, now just to throw some numbers out here, let's say, I'm just going to keep it simple here. Let's say initially I used 10 moles of iron 3 and 15 moles of the thiocyanate. We don't start with any product. I'm going to lose so much, right? I'm going to lose minus x plus x. Well, remember from the last test, if you know your initial is 0, for instance, it's going to increase by x, and then I know what it is. Well, guess what? This equals x. So then you come back over here and say, okay, well, 10 minus 5.09, I must have 4.91 moles of iron, and 15 minus 5, what is that? 9 point, oh my gosh, let's see, 91 moles of my thiocyanate, okay? At equilibrium. Again, based on the fact that I started with no product, I increased it by x, and I figured out what x was based on that calibration curve we did last week. Just be careful, these aren't going to be a 1-to-1 ratio. You're not doing 1 liter of solution. I just gave that as an example. You're going to have a molarity that you determine based on the calibration curve trend line. Plug in your absorbance from this second week, calculate your concentration. Mine was 5.09. Was way, way, way high. Yours will be pretty tiny. Again, I'm just throwing some numbers out there. And then once you have concentration and total volume this week is 10 milliliters, put that into liters and you can figure out how many moles of product are sitting there in your flask at equilibrium. So then you work it out for both. Okay, now I know, again, I'd used a 1 liter example just to be lazy for my own example. So I would say those were my equilibrium concentrations, moles divided by total volume. And then I'd say, okay, so then my KEQ for this first example equals, and whatever it equals, plug that in and that'd be your KEQ. Again, the lab's going to walk you through doing it through moles, okay? We work stoichiometry out in moles. So it'll ask you on the second page of the data sheet first how many initial moles of iron, how many initial moles of thiocyanate. Then it'll ask you to figure out how many equilibrium moles, and that's how you do it. You actually have to work through how many moles of product are at equilibrium, and that's equal to your x. Take your initial minus that x, that's the number of moles at equilibrium. Divide that by your total volume in liters, and you'll have your molarity of each. And then the last thing it has you do is calculate the K value, the KEQ or the KC, same thing. K is equilibrium constant, which is your product concentration at equilibrium, divided by your reactants concentration at equilibrium, and that'll be your K value. You do that for all 5 solutions this week, guys. And then at the end of page 2, calculate the mean KC for this, okay? So the average of those 5. You're not doing Part B, okay? And so again, when you come in tomorrow, Thursday, you need to turn in one for the team, your worksheet from last week, your calibration curve, and it's going to kind of look like this. Staple those together, and but write that down somewhere. Make sure you record what your equation was. And then today, or excuse me, tomorrow, depends on when you're watching this video, you're going to make 5 mixtures. Make sure you're grabbing the right concentrations and volume. You're going to use a total of 10 milliliters instead of 50. Pull out, you're going to run your spectrophotometers like we did, or colorimeters, sorry, we're using colorimeters. You're going to do it just like you did last week. You need to make sure you use 0 or blank it first. With what's the blank? Well, the blank is just going to have iron 3 nitrate in the lesser concentration. What is that? 0.002 molar. No potassium thiocyanate. So create a blank as well. So you almost have to make 6 mixtures, I guess. You need to be able to blank it first. Again, telling the machine when it shoots that light through your sample that the orangish color from the iron 3 nitrate is just that. It's from the reactant iron 3 nitrate and not the product. So one more time, the first thing you're going to do before you start running your samples, create a blank mixture. Use 5 milliliters of the 0.002 molar iron 3 nitrate. 0 milliliters of the potassium thiocyanate, and then 5 mils, just dilute it up, with 5 mils, but just dilute it to the line. Take a sample of that, put it in the machine, zero it, calibrate it, and then you're ready to clean your cuvette and load your 5 mixtures and record the absorbance. You're only doing, whoops, I'm sorry, I totally did this wrong. Method 1, not method 2. Only doing method 1, so you're going to record the absorbance of your 5. From there, you can calculate concentration of the product at equilibrium based on that calibration curve. That absorbance and that concentration goes on the first page. You'll notice the first page of the data sheet has a blank and then says times 10 to the minus 4. If you aren't in that ballpark, just cross off the times 10 to the minus 4 and write down whatever it is. Write down whatever it is. Okay, and then you're going to flip over to the second page, and there's a whole table for you to fill out. Initial moles of iron, initial moles of thiocyanate, equilibrium moles of both, and then equilibrium concentrations of actually all 3. From there, once you have these 3 concentrations, the equilibrium concentrations of all 3, you can plug them in the K expression, products over reactants, and calculate what the equilibrium constant, the Kc, is for each of the 5. It's a constant, so hopefully they're relatively close to one another. And then finally calculate the mean value, the average of the 5 Kcs that you calculate. Okay, don't do part B, that's where you stop. I hope this is helpful. You guys have a great spring break. I'm sorry about class yesterday. We'll start that chapter next week, or 2 weeks, I guess, when we're back from spring break. Bye.